Yesterday we started talking about the particle theory of matter. Who can tell me what the particle theory of matter tells us about the world around us? What do we know? What do we know about the universe around us? Yeah. Get all three of you. Good. So everything in the universe is made up of individual particles, individual something. If we cut everything down, eventually we get to something we can't cut. And that's an indivisible particle. Yeah. Okay. Yep, that's fine. What do you got?
All different things are made of different particles.
Good. So everything's made of particles, and my pen is made from different particles than my coffee cup, which is made from different particles than the coffee inside. All right? Good. What do we know about those particles, by the way? Someone tell me about, yeah. That's okay. That's okay. No pressure. Yeah.
All of them are constantly moving.
Good. All these particles are constantly moving. Now, shh. Here we go. Look here. What's moving faster? The outside of my coffee cup or the coffee inside? Which particles are moving quicker? The coffee inside. How do I know that? Yeah. Coffee's hot. And hot things are just particles more in motion. Why can hot things damage you? Because the particles are moving fast enough that they can bump into your particles and cause damage, right? Yeah.
Now I thought people say it's not really a good thing to take really hot showers.
Yeah, you could potentially, I mean, I in general, you'd probably say, I will say, my wife and I, the first house we rented had like a hot water heater shared between like a couple different apartments, and the hot water that would come out of that thing was unbelievable. Like it was deadly.
Yeah.
It was so hot. So like you had to like very carefully mix your shower beforehand, and then you had to go really quickly because if somebody decided to like turn the tap on in the other apartment, all of a sudden you were just getting scalded to death. So
Cold shower. That's my house.
Yeah, that sounds like a cold shower.
and so like I think if I was really irritating my wife, she'd just like go down to the kitchen and like, oh, there you go, Joe. Anyway, good. So particles that are moving fast, we experience that as heat. Particles that are moving slowly, we experience that as cold. And of course, heat is pretty much unlimited. Things can get faster and faster. Hey, really cold, if all other things being equal, if I have a substance and its particles are pretty cold, what is that substance likely to be at that point? Yeah, if I, sorry? They'd be moving slower. And if they move slow enough, what state of matter will they take on? Solid. What's a solid? Solid is when we have these particles and they are
Bunched up, like they're bunched together.
they're bunched together and they're held pretty packed tight. We can't move them, right? What's true about a solid at all times? Those particles are stuck together and it has what? It has a fixed shape, right? This book is shaped like a book, and if I put it in my backpack, it's still shaped like a book. But if I pour my coffee in my backpack,
It's still coffee.
It's shaped like a bag.
it's going to take the shape of my bag, and that's going to be very frustrating, right?
Yeah.
Does anyone ever have that happen? You have like your water bottle burst open in your backpack? Not fun, right?
Yeah.
What state of matter is my coffee in here? Shh. Hey, what state of matter is my coffee? I heard someone say it. Yeah, was it? It's a liquid. What's true about the particles in a liquid? Talking about the particles specifically in a liquid. Is that a hand? No? Okay. That's all right. Yeah, what do you got?
They're spread out, still connected.
Yeah, they're spread out, so they can move a bit more freely, but they are still stuck together. They're not floating freely. They're still connected. What's true about liquids?
They take form of the container.
They take the form of the container, but what don't they do? Yeah, the volume's constant. So I put my coffee in here, volume level goes down, right? If I had just a gas in here and I was pulling the air out of it, would the air move down and down? No. Does anyone have an air compressor at home? Maybe your mom or your dad has one in the shop, right? You can take that thing and pump tons of air into it. Does the air compressor get bigger and bigger? No, the gas just takes the shape and volume of it. And it'll keep doing that until eventually it puts enough pressure on it and it would like explode. Go ahead. Good. So solids, liquids, the last state of matter is
Gas.
gas. Gas. And in gas, those particles are
Everywhere.
everywhere. They will take the shape of the container, but they will also expand to fill that container, right? So the gas in this room fills the whole room. It takes the shape of the room. Those particles are constantly moving. And the thing is, any substance, any particle should have a gas form, a liquid form, and a solid form. When is it in its solid form? What has to be true about that particle to put that substance to put it in its solid form? If I want to take my coffee and make it a solid, what would I have to do?
If it's colder.
Cold. Now those numbers are different for everything, right? Water becomes solid at a different temperature than butter, at a different temperature than wax, at a different temperature than steel, right? But they all have a temperature at which they become solid. If I want to make it a liquid, I have to heat it up, right? And if I heat ice, it becomes water at 0. If I heat sugar, it becomes liquid at about 120 degrees Celsius. On the other hand, if I heat stainless steel, now I got to get to 800 or 900 degrees Celsius. I've got to get a lot hotter, but they'll still all become a liquid. And if I keep heating up a liquid, eventually every liquid becomes a gas. Does that make sense? Any questions about that? Awesome. Okay, today I want to talk about the second half of this topic. And it shouldn't take us long because it's pretty straightforward stuff. These may be words you've heard before, they may be new. Again, if there's one thing I've learned, it's that different elementary schools sort of teach different topics in science, and that's okay. That's not a bad thing. But today I want to talk about and mixtures. When you hear the phrase pure substance, what do you think?
Like, it doesn't have anything else in it.
That's a great answer. So it's some kind of substance and there's no other thing in it, right? Pure water would be just water. Pure gold would be just gold. Is there such thing as like, I don't know, like pure human? Well, no, because humans are made of all kinds of different stuff, right? Like if you want to make a human, you have to have bone and you have to have skin and you have to have blood and you have to have muscle, right? That'd be weird. Okay. So pure substances can be defined. I want to think in terms of particle theory. A pure substance can be defined as a substance that only has what? Yeah.
Only one type of particle.
Very good. Of only one type of particle. That's very good. Oh, the less common spelling of particle with no L. I'm assuming that's Spanish. Partis. Maybe French. That sounds French. Partis. If you ever want to make something sound French, fun fact, like if you're failing French miserably and you forgot to study and you've got like a test and you have to speak, just use a bad French accent and say oh at the end and you might trick her.
Or you can just put le in front of it.
Yeah, that's, oh yes, and le in front of everything.
Or just add
Because most French words are just similar to the English word with a bit of an accent, right? So like, you know, oh no, I forgot to le study for my le test. And she'll be like, oh my goodness, you're so good at French, A+.
Or you add more vowels and accents.
That's right, yeah, that's right. Pro tip. Okay, so I want to be clear about something because you guys already know about atoms, right? Right, we've talked about that a little bit. So for example, we know that water is made up of what? This is the one everyone knows. Everyone knows this from like grade 6. H2O, which means water is an oxygen stuck to 2 hydrogens.
Can we draw this?
Yeah, you can draw that. This is water. And even though it's got 3 atoms, they're always stuck together the same way. So that's still its own unique particle. Does that make sense? That's what a water particle looks like. And that is a pure substance because those aren't freely floating and moving. When you have water, it's not hydrogens floating over here and oxygens floating over there. They're always stuck together, just like this. Does that make sense? So this specifically, when we have some atoms stuck together like this, we call it a, maybe you've heard this word before? Has anyone heard that before?
Yeah.
Yeah, we call that a molecule. A molecule is one type of particle. Now, gold, on the other hand, is not a molecule. It is literally just gold atoms float stuck there together, individual atoms. So your particle could be just an atom. It could be a molecule, or it could be an atom. It could also be a couple other things, but we'll talk later about that. So when we talk about particles, we might be talking about just an atom, or we might be talking about a bunch of atoms stuck together in a specific way, and that would be a molecule. What's another molecule we talked about a lot last unit?
Sugar.
Yeah, sugar. Remember that was 6 carbons, 12 hydrogens, 6 oxygens stuck together in that certain way? That's a molecule. So sugar is a pure substance. What's another molecule we dealt with last semester, last unit?
Carbon.
Carbon dioxide is another molecule, right? It's always 1 carbon stuck to 2 oxygens. All right. So those are what we mean. Whoa. Oh, gosh. I'll get that. So what are some examples of pure substances? Yeah, water is definitely one. What else?
Hydrogen.
Yeah, hydrogen gas for sure. What else? Well, we said sugar. We said carbon dioxide. Yeah.
Ammonium.
Iron. And then, yeah, we could talk about ammonium, nitrite, nitrate, all those things, right? Yeah. So I think that's good, unless you guys want to spend like 7 minutes just writing things.
I don't. At least write down.
Lithium? Okay. I'm wired again today, and I feel so immobile. I like to walk around. But probably everyone sitting in the back is like, this is so wonderful. He can't come harass us today. Gentlemen, I really feel like I'm competing with you here. Just let me get through this, okay? Ladies, likewise. Now, the thing about a pure substance is this. When you look at a pure substance, what do you think it's going to look like?
Pure.
What's it mean for something to look pure?
Clean.
Yeah, I mean, that doesn't have to be clear. Like iron and lithium aren't clear. Sugar isn't, well, sugar is clear, actually, if you look at it under a microscope. What do you think, Kat? So the same color all the way throughout. Yeah, the same color. And if it is clear, the whole thing should be clear. Yeah, can I teach you the science word for it? We say that a pure substance has just one phase. Phase. Kind of a strange word. Phase. But when we say phase, what we mean is this. Shh. A phase is a single physical appearance. All right, and it includes such things as color, clarity, right? Like if you can see through it, if it's clear, if it's opaque.
Shape.
No, not shape. Shape doesn't have to. These are the two main ones. Color and clarity. Yep. Yeah, so that's a good point, actually, is state. All right? So if something's in a single phase, it'll all be the same state. It could be any of the states. It could be a liquid, it could be a gas, it could be a solid. But if something has one phase, so if something has a single phase, then it has a single physical appearance. It's all the same color throughout. It's all the same clarity throughout. It's all the same state throughout. And a pure substance always has just one. So if you look at water, pure water Pure water, all of that water looks clear. All of it has that kind of like light blue tint that we get from water, right? It's all liquid all throughout. That's what a pure water is. And I know that water could be a solid, but if we looked at ice, now it would all look the same throughout.
I think we get that also that too from the bottle.
Yeah, water does have, it does give you color. Like if you look at like an ocean, for example, there's no bottle there, but it has a definite blue tinge to it, right? It has to do with what it does with light, which you'll learn all about in grade 10. All about in grade 10. So a pure substance is pretty easy to understand. Now, the other side of the coin is I want to talk about mixtures. I'm getting on the road, walking around, and then I walk back. Yeah, no escape, no rest for the weary, as they say. So, what's a mixture? What's a mixture? Yeah, what do you think? Yeah, good. So 2 or more things put together. Kevin, what were you going to say? Yeah, good. So taking 2 more things and mixing them together to make one thing. That's great. Those are good. It's exactly what it sounds like. That's good. Specifically, it's a substance that has, if we go back to particle theory, what would I say? A substance made up of, yeah, a substance made up of more than one particle, type of particle. So if I take water particles and salt particles and I put them together, I now have what we would call salt water, right? That's a mixture. 2 different particles put together. The water that comes out of our tap is a mixture because there's water in it, but there's also other stuff. Right? There's chemicals in it. There's runoff from farms. There's stuff that they intentionally put in, right? We put fluoride in our water. That's part of our treatment for it. We put a little bit of iodine and chlorine in our water. No? Okay. And I want to break mixtures down into 2 types, into 2 categories. That'll be it for today. The first is what we call a mechanical mixture. You know what this is? Yeah, what is it? Sorry? Yeah, so you can definitely make it for sure. Here's what I want to do. Sometimes I think it helps to draw a picture. So I want you to imagine this. Imagine I have a beaker. Oh yeah, come on. Let's all draw together. This can be like art class. It's a beaker. Isn't it lovely? I think that's very good.
I do.
All right, I'm going to try again. Now you've made me self-conscious about my beaker drawing skills. I hope you're happy. If your goal was to make me self-conscious about my artistic skills, well then mission accomplished.
And over time,
What is that? Is that you get an A+ in art?
Thank you
for trying. I would definitely.
for trying.
It's the attempt that.
Let me tell you, I've taken art and I did not get an A+. Okay, so if I had water in my beaker, so I have a beaker with water, then I would like you to imagine that I have a pile of nails.
Oh.
All right, so I've got a beaker and I've got a pile of nails. So I've got water and I've got
Nails.
a pile of nails.
You just restated it twice.
If I take my pile of nails and put them in the water, what do I have?
Nails.
Water and
nails.
Yeah, very good. I now have a beaker full of nails.
Naily water. Naily water.
That's right.
They're rusty.
You nailed it.
They're rusty.
That's right. I now have got a beaker full of nails and water. This, by the way, is what I think is going to be Canada's next health food sensation.
Nails.
Nail water. Nail water. Made with 100% pure Canadian nails and tap water. You're coming in today, yeah? Third period?
Yeah.
Cool. Yeah, it's all great. do you want, like this computer's hooked up, that's fine. Are you going to be used back there? Do you want that section cleared off? Perfect, okay. Yeah, Smokeboard will be all set up for you. Great. Yeah, so we end up with nail water, right? And what do you notice here about this? You can see the nails, definitely, right? The nails do not disappear. Now, if we left them long enough, something fun might happen. But just in that first minute when we mix them together, it's just nail water. Yeah.
But if you mix rusty nails with Coca-Cola, you get clean nails.
It's true. That is true. So, here's a mechanical mixture. A mixture
You're gonna show your
That's a valuable life skill. What did you learn today?
I learned it.
Listen, what I wish is that we took all these classes and like, I wish you could go to business and like you'd learn all about marketing nail water to, you know, and then in math class you could learn all about like, you know,
How to measure how deep
yeah, figuring out the volume of water and the volume of nails and what percentage it is. Okay, where the substances are individually visible. All right, so a mechanical mixture means I take a bunch of stuff, I mix it together, but I can see the individual parts of it. I can see the individual parts of it.
Is that how you spell visible?
Yeah.
Are you sure?
So first, I'm sure it's how I spell visible. But secondly, I'm about 80% confident it's how like
Invisible.
the dictionary also spells visible.
Do I need to know?
But never 100, but I'm pretty confident. Okay. Shh. Now, I want to go back to this more formal language we've been using. We say that a mechanical mixture has more than one phase. What's a phase again? What's that word mean? Phase. Yeah, Bella, what do you got? Yeah. A phase. It's just a phase, Mom. Well, in this case, our nail water is going through two phases all at once. So, if we look at our nail water, there are two distinct visible phases. There is the water, which is clear, mostly colorless, right? Liquid. And then that's one phase. And then we also have the nails, which are not clear, they're not colorless, and they're not a liquid. They are, in fact, kind of gray, shiny gray. They're solid, or rusty maybe, right? And they're not clear, they're not transparent, they're opaque, which is a word we'll learn more about tomorrow. So we can see each phase separately.
Wait. I did it wrong.
And I want to introduce you to a word that I didn't see it when I looked at your textbook, but I know it's going to come up in grade 10. And so I thought, why not introduce you to it a little sooner? And I think I've never taught this course before, but I imagine they always teach it. But we say that a mechanical mixture is heterogeneous. Oh yeah. Yep.
One big word.
Yep. One word.
Yep, we usually teach that word.
Do you 9? Yep. Nice. Good. Good to know. So heterogeneous means well, interesting actually. I mean, so the word heterosexual comes from the same root. It has the same prefix, and we'll talk about what that means. So well, this is an interesting problem to have. Okay, listen. Hetero just means different. So when you see the prefix hetero, it means different. So when we say that somebody is a heterosexual, it means that they're attracted to somebody of a different sex, different sexual identification. Makes sense, right? Shh. Exactly what? Oh. Shh. So in this case, different, and then genius literally, oh.
Genius.
If you think about it, it comes from the same root as Genesis. Genesis, first book of the Bible, is the book of the Bible that talks about what? The beginning, about the creation, right? The making of the thing. So literally this means, made of different things. And you can see that, right? It's made of different things, and you can see that. That's like the root word of it. This one doesn't work beautifully. Sometimes the words, you go from the Latin to the English, and it tells you exactly what it means. This one's a bit of a stretch. But heterogeneous means that you can see the different elements of it. Now, the other kind of mixture we call a solution. And again, I like to draw a picture. So again, I'm going to start with my nice little beaker.
There we go. This wonderful and beautiful picture.
There it is. And I've got water in my beaker. But this time I'm going to get another little beaker.
Oh, you're mixing it up.
Yeah.
Mixing it up.
And I'm going to put salt in my beaker. I'm going to mix them together. I'm going to pour the salt into the water, because if I poured the water into the salt, it would overflow. And when I do this, what do I see? Yeah, do I see water with a bunch of salt particles all spread throughout it?
No. You see,
I mean, maybe if I put a bunch in, but if I just put a bit of salt in, do I see that? I don't, do I? It dissolves. So when I put the salt in the water, I get salt water, but unlike my nail water, what is now true? What's true about the salt water that was not true about Mr. Orlando's patented cure-all nail water? Yeah, what do you think? Yeah, it disappears. It disappears. We can't see it. Now, does that mean that this is pure water?
No.
But it looks pure water, doesn't it?
Yeah.
And this is the thing we have to keep in mind. If I put 2 bottles of water up here, and I said one of these is pure water, and one of them is water and deadly poison, could you see which is which?
No.
No.
Unless the poison is color.
Just take both.
Now, on the other hand, if I said 3 bottles up here, one of these is water, one of these is salt water, one of these is water, one of these is salt water, one of these is Mr. Orlando's patented nail water, here's what ails you. Would you be able to tell which one was which?
Yeah.
Well, you'd know which one was the nail water, but not the other 2, right? So, it won't actually. Now, if we add too much, yes. But if you add just enough salt or less, you can mix it and it will never settle out. Never. It can sit there for, yeah. So we define a solution this way. It's a mixture where we cannot see each of the substances. How many phases does a solution have? How many phases does a solution have? What do you think? 1, because what is a phase? No, but what's a phase? The phase itself is the the visual, the physical appearance of it. So even though this is more than one substance, how many phases does it have? My salt water just has 1 phase. The whole thing is clear. The whole thing is colorless. The whole thing is a liquid. Right? So only 1 phase. Even though there's more than 1 particle type. Now, we said that a mechanical mixture, which has 2, 3, 4, 5, several phases, we said that it was heterogeneous, that it was made up of more of other things, and we can see those other things. What do you suppose we are going to use to describe this? So the mechanical mixture is heterogeneous. Hetero means other. Okay. So it's going to end in genius as well, because it's. So this still means made up, right? Yeah, which again isn't really a great. It's not actually a great word, to be honest, but that's okay. But instead of hetero, instead of being other, what's the Latin word for same? That's right. This is homogeneous, right? If somebody describes himself or herself as homosexual, it means that his or her sexual preferences are for people of the same sexual identity, right? Homo means same. Yeah, that's right. You are. In fact, all of the great primates, all of us human types, we belong to the family Homo, Homo sapiens, Homo habilis, all these things. So, yeah, I'd love to. So, if we mix things together and they appear all the same, that is a solution. And solutions are homogeneous. Sometimes you'll hear it pronounced homogeneous. Have anyone heard that before?
Yeah.
Homogeneous? Yeah, like homogeneous milk. Homogeneous milk is actually stupidly named because all milk is homogeneous, but its name comes from the manufacturing process. For homogeneous milk, they take the milk from the cow, and then they put it in a bag. There you go, homogeneous milk. Whereas to make skim milk, what do they have to do?
Skim it.
So before they can skim it, what they have to do is separate it into its two parts, so that the fat's on top and the water-based parts on the bottom, and then they can remove some of the fat, and that's how they make 3% and 2% skim milk. They separate milk. They make milk heterogeneous, so they can break it into its parts. They take some of the fat away. They use that, by the way, to do what? What's milk fat used to make? Butter, good. So they make butter from the milk fat, and then the remaining milk, they re-homogenize, but now it has less fat than it started with. Does that make sense? So when they call homogenized milk, all milk is homogenized, but the homogenized milk stayed homogenized the whole time. It was always a pure solution. It was always a solution. Whereas, to make 3% milk, 2% milk, skim milk, they take the milk, make it heterogeneous, they make it into its separate phases, they skim off the fat, and then they re-homogenize it. Does that make sense? Because you wouldn't want to get your milk and have all the fat at the top and the liquid at the bottom. That'd be gross. Right? Big old like thing of butter at the top, and then just like gross, clear like white liquid at the bottom. Yeah, not cool. Okay, and I just want to mention, that I'm not wearing it today. That's unfortunate. I was going to do the big talk about my wedding ring, and I'm not wearing my wedding ring. But that's okay. Can I tell you? I'm on marriage. I'm on marriage 1, which is good. I'm on wedding ring. I have a habit of losing wedding rings.
Does your wife buy it or you buy it?
Well, I just switched to buying just cheap ones. I wear a stainless steel wedding ring now because I lose them, and I quite like it. And I quite like my new one, but it's cheap. But yeah, I lost my first wedding ring on my honeymoon. That's rough, right? We were poor. We went to Niagara on the Lake, and that was enough. It was gone. It didn't fit yet. So anyway, yeah. But we can talk here. This is made of stainless steel. Do you know what steel is made of?
No.
Steel. Isn't it like iron and?
Anyone know? It's actually iron and carbon put together. You mix them together. But can you see bits of iron and bits of carbon in here?
No.
No.
See iron.
Someone know brass? Something's made of brass.
Oh, that's copper and zinc.
Very good. Yeah, very good.
It's right there. Yeah.
So an alloy is when we take metals and we mix them together. Now, what are we going to have to do to metals to mix them together? Melt them. That's right. So if you take lead and tin and mix them together, you get something called solder. Does anyone know what solder is for? Yeah, so one of its two uses is to connect electrical components. So if I have a piece of wire, maybe copper, maybe aluminum, whatever, and I have an electrical component and I want to stick them together, I can heat up solder till it melts, drip it, just drip it onto there, let it harden again, and now you've got metal holding your electrical component to your electrical wires or to your board or whatever. That's soldering. Where else is the major place, like all of your homes contain a lot of soldering? Anyone know? Yeah? The piping, good. If you ever get a chance to learn how to solder copper pipe, it is one of the world's most satisfying experiences. It's really, really fun because, do you not enjoy it? I love it. You polish down. Okay, there is that. I have also almost burnt my house down. But failing that, it's great. You polish a piece of copper up, and then you polish the other piece of copper up, and you fit them together, and they dry fit, and then you heat it up with a torch. And you get good and hot enough that the copper won't melt, but what will melt? The solder. And then you actually, if you're doing it right, you take the torch away. You shouldn't actually physically have the torch there while you're doing this. And you just take the solder, it comes in a wire, and you just put it in a ring around and it melts. And you can actually see it go like, and like suck in and fill that void in. And like, cool, those two things are stuck together. They're tight. Yeah.
It only works good if you're using two new pipes, not just a new pipe and like a 70-year-old pipe.
That is true. You really have to scrub it down so you have nice, fresh, shiny copper. Because yeah, it does not work, and it will definitely spring a leak. The worst soldering experience I ever had. I was renovating my basement. I installed a whole new basement, bathroom, kitchen, living room. We made like a basement apartment in my previous house before we sold. So we sold it as like a duplex, so somebody could live up top and rent down the basement. So I'd done this whole thing. I dry fitted it all. It was all good. I checked it out. I went around and I soldered everything. And it's like, felt good about it. I dried it. I cleaned it. And I said, okay, now I'm ready to pressure test it. So I went to the water supply. I turned the water supply back on. And I was walking around checking all the fittings, making sure they weren't leaking. And they weren't, and they weren't, and they weren't, which was great. But the whole time I was doing it, I hadn't soldered an end cap on the piece of pipe coming out of the wall in the kitchen. And so while I was doing this, water was just flooding into my basement kitchen, and I'm in the bathroom checking all the fittings. And then I walked into the kitchen and it was just like water just like gushing into the thing. It was a disaster. I had to re-drywall the whole thing. It was not my finest moment. So my soldering was good. My common sense, not so much. Okay, so we call that when we make a solution, when we make a mixture out of different metals, we call it an alloy. The classic one is gold. If you have a piece of gold jewelry, is that pure gold? No. In fact, you may have heard of like 12 karat gold, 24 karat gold, 16 karat gold. None of those. Good. So a carat is just a measurement of weight. So they define the carat by how much the gold weighs, because when they mix other metals with it, gold actually gets lighter. Gold's a pretty heavy metal. It's actually very, like, you ever see like those gold bars on TV? Well, those gold bars are way heavier than you think it is, because gold is a very relatively heavy metal. It's much, 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 much heavier than iron. So if you have, imagine like someone lift weights. I used to lift weights before I thought lifting food was more fun. Yes, yeah, it's good exercise. But if you lift weights, those are like, you put a 50-pound weight on each side and you curl it up. So I want you to think about this. If those weights were made of gold, and I want to get the correct number so I don't mess you up, it is 4 times as heavy. So if you had the same size weights on your barbell, but everything was made of gold instead, it would be 4 times as heavy. So a 100-pound setup would become a 400-pound setup. So think how impressive you would look if you were lifting like pure gold weights. The only problem is, and why don't we use pure gold? If I had all that weight on a gold bar, what would happen to it? It wouldn't even break. It would bend. Because gold is it's really heavy, but it's really soft. It's really, really soft. Which is why if you get jewelry, not only is it cheaper, to make it a mixture where we take part gold and part other metals and make an alloy. So part of what we like is it's cheaper because gold is very expensive to get out of the ground and very expensive to buy and sell. But it's also a lot harder. A lot harder. Gold is very soft. And so if you had a pure gold ring, it would be really sensitive to being scratched and being damaged and things like that. So we mix it with other metals.
What's white gold?
White gold is pure gold mixed with, I'll look it up for you tomorrow. But it's a certain mix of alloys that it is real gold, but the alloy mix takes its color away. So it ends up looking white.
Did you know there's a gem that they make out of trash?
Yeah, you can compress, I mean, you can compress anything into diamonds now. You can pay a company to have your ashes compressed into a diamond.
You can also get turned into a
Weird.
record.
Someone's going to be wearing you a diamond.
Yeah. I don't think I support that. Okay, guys, that's all for today. We're going to head up to 162 and you can work on, I want to mention, hey, we'll get a bit more time tomorrow as well. I want those final submissions of the formal lab reports, but also, if there's anything you owe me from Unit 1, and you can come ask me what that might be, Monday's the day. If I don't have it by Monday, I'm never going to have it, okay? Let me take a look for it. I don't think, let me check. Yeah. No problem. Where are you going, by the way?
We're going to mentor some
Wonderful. That sounds good. Are you going now?
Yeah.
Perfect. Have a good time, guys. We just took a note about, and it was just what we talked about, called the particle theory. And I can give you this for you to get down. So it was just what we talked about in the beginning.
Did you do attendance?
No, but I will. Let's take a look. Let's just make sure we know.
All the people that just left.